Hello, I'm your host, Georgios Lilis, and together with me is Dimitrios Mavrokapnidis, who is a research fellow in the Smart Buildings and Digital Engineering Group at University College London. Our team is leading in the development of semantic data models and ontologies in the DigiBUILD project. In this episode, we are diving into a critical enabler behind all the digital tools and services you've heard about, and that is semantic interoperability. Semantic interoperability allows different systems and data sources to understand each other and act in unison. So, hello, Dimitri. So I will ask you some questions.
Hi, Yorgo. Thanks for the introduction.
Let's see. To start off, what is exactly semantic interoperability? Can you give us more details and why semantic interoperability is important in DigiBUILD?
Great. Thanks, Yorgo. So yes, semantic interoperability basically ensures that systems don't just exchange data, but they basically interpret it consistently. Specifically for the project, in the context of the built environment, we're dealing with a plethora of heterogeneous data produced across different stakeholders, life cycle stages. This could be IoT sensors, building automation systems, BIM models, APIs, weather data, and more. And each data source uses different formats and structures. So now imagine trying to build a smart service like forecasting energy use for a specific building with data that's basically inconsistent and ambiguous. You simply can't, and this is where semantic interoperability becomes crucial. So in DigiBUILD, we're building a unified digital ecosystem, a kind of data space where systems and services can work together across different buildings and pilots. So for that to happen, we need a shared understanding of what the data means. Take, for example, a temperature reading. It's not useful unless we know where it was measured, how, and what it represents in the bigger picture. So without that context, the data is meaningless. So to enable semantic interoperability, we use what is called ontologies in order to add context to data and improve basically the data quality and ensure that data can be reused for application development within the project.
So you mentioned ontology. So from your description, I get a feeling that ontology is a kind of a vocabulary in technical terms. Can you give us like an explanation in simple terms? Let's say, what is ontology and how ontology is useful within DigiBUILD?
Great, thanks, Yorgo. Yes, sure. So basically, an ontology, you can imagine an ontology as being a dictionary, but one that machines can actually read. And it also allows us to describe how things are connected. So instead of just saying this is a room and this is a sensor, we can describe that the sensor is in the room and measures air temperature specifically. So this structure allows software and machines basically not to just read data, but understand the context and the meaning. And basically that's very important because it lets services work across different buildings or tools without custom coding each time. In short, ontologies bring logic to data. In practice, an ontology defines concepts, entities, and relationships between them. For example, instead of just knowing that there is a sensor in the room, an ontology defines that the sensor is in the room. Basically, this is quite important because we can now then reuse this data and understand how it's been used to measure specific aspects like temperature.
So what kind of ontologies do we have in DigiBUILD? Can you give us examples?
Yes. So basically, to support the requirements of the project, in DigiBUILD, we've adopted a modular approach. We've created the DigiBUILD ontology, but it is very crucial to mention that we didn't start from scratch. We built on existing standards like brick schema, the building topology ontology, SAREF, the real estate court ontology, and we stayed fully aligned with them. These are widely used in the building and energy sectors, so we knew it was important to stay compatible and ensure semantic interoperability with the most popular schemas in a way that we could enable the reuse of our work. So what we did was that we extended, after mapping the requirements of the services, we extended and connected these standards to support the specific needs of the project. Things like comfort indicators, energy performance metrics, EV charging data, and so on. So we added new relationships where needed to describe things like sensors, room, and schedules, and how they're linked to each other. The result is a flexible, reusable ontology that is already public and can be reused from other developers that helps us describe not just one building, but a whole network of buildings and pilots, and also support how the smart services can run across them. Yes.
So you mentioned smart services, and I was thinking another important aspect, and it's also an important concept in your work that is related somehow, right, to services, is computational quantities or CQs. Can you give us some examples, or can you explain the concept and why this concept is important within DigiBUILD?
Mm-hmm. Of course, yes, absolutely. So this is a core innovation in the DigiBUILD ontology. So computational quantities, or CQs in short, are a novel way to make services portable across different buildings. Let's use an example. Imagine, for example, that we need to extract a mixed air temperature in air handling unit. In a specific system like this, that might be directly measured by a sensor. In another system, though, it could be estimated using other sensors, like the return air temperature and the outdoor air temperature, and calculated from those. So basically, the way we calculate something that we need to support a service can be very different from across different deployment sites. So basically, a CQ, what it does is that it offers an abstraction, a simplification, let's say, that defines the intent of the measurement, not just how to get it. So by using CQs within our ontology, the developers can basically build a service referring to quantities like CO2 concentration or heating demand, instead of focusing on how to extract data from different pilots.
So that sounds really promising, and also helps in terms of scalability. It can grow in, supporting very complex building services. So by developing an ontology and also CQs that might be very complex, you're facing a lot of challenges. Mm-hmm. Can you give us some examples of the biggest challenges that you're facing?
Yes, as we've already mentioned, the biggest challenge in the built environment is data diversity. As you know quite well, every building is different, is unique. There are many different naming conventions, sensor setups, different protocols and formats. So aligning all that under one shared structure was quite complex process. So another challenge was balancing richness with usability. So we wanted to create a model that was expressive enough from one point of view to support the services, but at the same time not so complex so that it becomes too hard for users to interact with it. So to enable and ensure that these models that we use the ontology to generate semantically rich and valid models for each pilot, we've developed various tools like methods to automate the mapping of data using our ontology, template-based generations. We also used complex validation processes to ensure that all the semantic models are rich and valid and meet the requirements of the DigiBUILD services and digital twins. Maybe if I add one more, ontologies aren't static. So as services evolved, and as a result, the data the data needs were evolving. We need to make the framework modular and extensible so that we can support the growing requirements.
So you mentioned services a few times. So can you give us examples on how the ontology developed within DigiBUILD support the DigiBUILD use cases and related building services?
Yes, certainly. Let's use energy forecasting as an energy forecasting service as an example. To build this service, we need to understand, for example, the current and historical energy use, predict future demand, and correlate that with the weather conditions and occupant behavior. So thanks to the ontology, all of those variables, temperature readings, energy consumption, weather data, are semantically defined. So the service can pull them from any building without custom integration and reconfiguration across different sites. Other examples include fault detection, EV charging, optimization, comfort analytics. Those are just some of the services we're going to speak in later episodes of this podcast. But basically, our ontology makes it possible to support all these different services using a single uniform representation of data and contextualized as well.
Okay, so let's take a step back and try to, let's say, paint the bigger picture of DigiBUILD. So how do you think this data model and this work, the data models and this work and the ontologies developed are related to the bigger goals of DigiBUILD?
Great. So yes, I'd rather say that an ontology, the ontology, the DigiBUILD ontology is rather the foundation of the entire project. Because in DigiBUILD, what we create is a federated and rich data lake, basically a platform where high quality building data can drive smarter decisions, better policies, more sustainable outcomes across the different projects that we have in the EU and across the different partners. So the ontology that we've built ensure that this data is discoverable, interoperable, and more importantly, trustworthy and reusable. And this allows services to work across different buildings, districts, and even countries across our pilots. So in short, I'd say that without this semantic foundation, the DigiBUILD ontology, none of the higher level services like AI services, digital twins, and dashboards that we've developed would be possible to scale and be reused across different buildings.
Thanks, Dimitrios from UCL. So if you want to learn more about how these ontologies are being used in real buildings and how semantic interoperability is supported using these ontologies, be sure to check out our next episodes. Thank you.
Great. Thanks, Yorgo.